the first step is, I think, to be more precise, is that the ever-increasing implementation of technologies in the workplace involves paradigms that can strongly interact both with humans and technology. And the implementation of technological innovation is, of course, advantageous for companies. We know it ensures significant benefits in terms of cost, management, and so on. And it allows to enhance employees' safety. However, at the same time, technological innovation require an update of the analysis of risks to the workers. For instance, new injuries should be taken into account, as well as new potential causes of diseases or new hazards caused by new activities or procedure. So, among the many, we can mention just a few risks in this minutes we have. This list of risks, I took this list from the report of the European Agency for Safety and Health at Work, named OSHA, they incorporated the impact of ICT in the list of research priorities concerning occupational safety and health. In this way, these agencies stress the need for an integrated and proactive approach for the identification of emerging hazards related to the changing workplace. Additional risk, of course, emerge concerning new human-machine interfaces and a growing number of interconnected objects or individuals. As a consequence, organizations and companies face new challenges. Among the many, the first is, for instance, the use of automatic guided vehicle, AGV. The use of this AGV provides the possibility to revolutionize the company's logistic or manufacturing organizations. They ensure efficient and flexible maneuvers with minimal manpower, high productivity with low cost, and continuous handling operation. They also can be designed to interact with other automated systems, such as automated storage and retrieval systems. However, in this context, it is challenging to develop a flexible and automated system while also guaranteeing the safety of the humans operating in the same area. But again, the implementation of augmented reality and virtual reality is often, on the one hand, beneficial in working environments because they allow to keep workers away from dangerous workspaces. They also support workers during different working phases in terms of procedures, in terms of hidden hazards. But nevertheless, these systems pose new health and safety hazards for the worker. For instance, the implementation of these technologies is often connected to chemical and biological hazards. And as far as ergonomics is concerned, operators may experience discomfort deriving both from the dimension and the weight of the devices and from the stereoscopic display vision. And additional factors may also lead to muscle fatigue, pain in the lower neck area, shoulder pain, and so on. Third, the use of exoskeletons. In this regard, the French Research and Safety Institute for the Prevention of Occupational Accident and Disease, the name is INRS, I think, provided an overview of these new risk factors in the workplace connected to the use of exoskeletons. On the one hand, exoskeletons can help. Again, you see, it's always a twofold vision. On the one hand, they can help reducing muscle tension in the workplace, support workers with impairments. But on the other hand, exoskeletons may pose new hazards for worker safety and health. Electrical hazards derived from the energy released from these devices, they are shut down, power failures, which may cause unexpected behaviors of these devices, or generate uncontrolled energy release and so on. And again, smart wearables are, used in production environment to monitor working conditions, report risk situation when necessary. The most widely used solution are GPS monitoring of the worker's position and the monitoring also of biological and physical parameters, heart rate with smart bracelets. But also further smart solutions include the use of smart helmets or smart belts. But in these contexts of, again, specific risks for the health and safety of workers arise electrical hazards may derive from possible electromagnetic interference between these devices and, for instance, medical devices, subcutaneous medical devices of the workers. The exposition to electromagnetic or ionizing and non-ionizing radiation may cause also superficial damages and also genetic mutations. The last case I want to mention is the case of cobots, because it has been the specific case study we analyzed in our research. Cobots is the name for collaborative robotics, as you probably know. The implementation of this kind of robotics within production systems can, on the one hand, minimize the need to work in hazardous working environment, for instance, narrow or high altitude space. And also they allow to perform routine or repetitive tasks on fast, precise, and tireless way. And also they facilitate access to work for people with physical impairment. Although these technologies may pose several hazards, again, for the users. First, mechanical hazards may derive from the movement of mobile parts, for instance, arms, limit switches, and other terminals, or from the rotational movement of any axis of the robot or cobot, and from the operator's inability. And additional mechanical hazards include damages caused by the fall or expulsion of materials, products, and tools due to inadequate grasp of the arms of robots and cobots, and so on. So it is just a very brief overview of some of the risks, but again, of the opportunities that these technologies can give in the workplace.